Hey, everybody.
Good morning, everybody.
Hey, everybody.
Good morning.
Hey, Brother Murdoch, did I miss anything important from this meeting, from the morning meeting?
Yeah, Felipe was there, which was
cool.
good. Seems to be picking up a bunch of learning some things.
Yay.
And yeah,
I just had my religion class, sorry.
yeah, no worries. That's the main thing.
Okay, cool. And then I just got your announcement about the internship. I don't know, because I was going to go to school this fall. Could you do it part-time?
I don't think so. I
Okay.
think this one, Brother Godfrey worked really hard to get a full-time thing, and it took a lot of red tape to get it. And so I think he's hoping to have a full-time
Okay.
person.
Was it just one or how many people?
There's two
Two.
separate openings.
Oh, okay, cool.
Yeah.
I'll probably just keep on doing like the 5-10 hours a week then.
Yeah, it's great experience. Sometimes
Yeah.
slower helps, at least for me. Sometimes doing less on something is actually better. Like a little bit of it every day is better than a lot of it every day. It seems like there's an element of time with learning that you can't overcome sometimes.
Sure. And I mean, yeah, it's just my first semester back, so
Yeah,
I got plenty of time.
Temper yourself a little too. Yeah.
Yeah.
Hey, Brother Miller. I'm sorry I was a little late today, guys. I was just trying to get ready for class. I think Brother Miller's going to have me do, and there you are.
We're good. We're good to go.
Okay.
Everybody's happy. Who wants to pray?
I'll say the prayer.
Awesome.
Our dear most gracious, loving Heavenly Father, we that children by this beautiful morning, thank you for all the blessings that thou hast given us, and as we have come to attend this class, help us so that we may be able to learn and remember what we are learning. And we ask thy blessings to be upon us always, and thy spirit guidance, and to be with us and guide us, and so that we may always walk in a righteous path. And we ask thy blessings to be upon us, and we love thee so very much. In the name of Jesus Christ, amen.
Amen. I forget how many of you still, let's do, go to your participant panel and raise your hand virtually if you are still in Rexburg or again in Rexburg or the surrounding area. One, two, three.
I'm about half an hour away. Does that count?
Yeah. A little less than half of you only. It's got to be more than that. No? Maybe that's it. Not in Rexburg? Okay. Well, it's finally getting nice here. Like the good weather is here. It's just beautiful right now. So we're enjoying getting out and pretending like we know how to raise a garden and playing outside. So hopefully you guys are having a good summer. Anything exciting going on we should know about?
Yes, my cousin is getting married soon, but
Awesome.
I will not be able to be there for her wedding.
Darn it. Yeah. Bittersweet.
Is it a traditional marriage or is it a non-traditional marriage?
It's going to be like a traditional Indian wedding, but I think because of this COVID and stuff, they're going to take it like they will try as much as possible to take it simple, because Indian weddings are huge and like really, it's very hard to make it simple. So they're trying their best.
That's like us having to adjust to teaching on Zoom. It's going to take some serious restructuring, thinking, and challenging previous preconceived notions on what can we do to really, like, what are the essentials here. It's not easy. I don't know. I'm oversimplifying by saying that, but you know, it's just we're all trying to do that in life right now. So it's interesting. Okay, cool. I don't see anybody signing up for the purifying thought, but I think we had someone say in class that they were going to do it today. Is that right?
That was me.
Andrew, thank you. Do that.
All righty. Okay. So for me, recently, I've been, thinking about what makes me fear things. What makes me fear certain things? Could that be the environment that I grew up? Could that be people that I was around that, they'll place limitations on me and say, you don't have what it takes to do this. I mean, and one thing that I really like, and something that I just, over these past few days that I've been reading some motivational books, I really feel that faith begins with how you talk to yourself, how we talk to ourselves. And while I was thinking about, there's a scripture in James where he talked about the power of our words, or the power of our tongue. I would just like to read one verse from there. It's James chapter 3. Chapter 8, verse 8 says, "But the tongue can no man tame, is an unruly evil, full of deadly poison." And I'll also like to read 10, verse 10. It says, "Out of the same mouth proceedeth blessings and cursing. My brethren, these things ought not so to be." So how we speak to ourselves. I often see this, and I've fallen into that trap where, you say, I'm bad at coding. I don't think I can code. I don't think I can do this. And I feel that the more we tell ourselves that, we cannot do a certain thing or task, it just goes into our brains, and it reminds us every time that we want to do that task. It reminds us that, hey, remember you said you cannot do this. And just the thought of that, leads us to fear certain things. It leads us to have that fear that we cannot do it. We are not good enough. So I strongly feel that is very, very important on how we talk to ourselves, like avoiding negative talk, self-talk to ourselves. And I remember last time I shared that I'm a big fan of affirmations, and there's one that I like so much that I usually try as much as possible to say to myself. It says, "I can do hard things through Christ which strengthens me." And every time I find myself in that trap of saying that, "Oh man, I don't know if I can do this. I don't know if I have what it takes to do that." And that has helped me to overcome those fears, to overcome the fear of trying something new. I often tell myself that, well, it's hard, but it's not impossible. It's doable. With certain steps, I can be able to achieve that. So my plea to each one of you, my dear friends, is to be kind to yourself, to talk positive to yourself, and not to fall into this trap of telling yourself that you're not good enough, that you don't have what it takes. Because the moment you do that, it goes into your subconscious, and it reminds every time you want to try that something out new, your brain will remind you that you said you cannot do that. And that builds up a lot of fear. And that's what I just wanted to share with each one of you today. That make that as a daily habit to talk positive about yourself.
Thank you so much, Andrew. I'm just going to say that I felt the spirit as you shared that. That's all I think I need to say. I can feel the power of the introspection that you've done there and the truth of what you've said. And I may have a couple thoughts I might want to tack onto it when you post it on the board. If you could post a summary of that on the board, I've got some responses that I've thought of, but I just want to leave it at that for now because that was powerful. So thank you.
My pleasure.
Brother Miller, I'm ready today to do however much of the learning time you want me to.
Okay, let's do that. Let's go for it.
Okay.
Let's jump in.
Okay, cool. We're gonna play a game today. I think it will be a fun one. We'll see. You guys can be patient because I've never done this before. So I really appreciate you guys. You're always helpful. So I'm not concerned about that. So we're actually going to have you guys practice what it's like to be a pod in Kubernetes. So each of you are going to be a pod today for a short time. And each of you is going to load an image, which is a calculator. So you're all going to be a calculator today. And depending on what team you're on will depend what operation you're going to need to do. So we're going to stick with our typical teams today. So team 1, 2, 3, 4, and 5. And I will pull up a reminder of that, who is on which team. So team 1, team 2, team 3, team 4, team 5. So we're going to start with team 1. And again, like I said, I'm sure you guys will be really patient because we're still learning how to do this. So what I want you to do, all of you, is get a calculator, whether it's on your phone, on your computer, somewhere, pull up a calculator. So for me, I'll just show you if I can do the right one. This is the calculator I use on my screen, not this one. Get it to come over here. Now, I'm just realizing that square root is not on here and square is not on here. So we're gonna have to probably.
You can change it. It's on there.
Is it?
Yeah, you just have to change the settings to scientific or something.
Oh, there we go. Scientific. Ah, cool. Okay, so if you're on team 1, what I want you to do is have a calculator and we're going to just do a practice problem. So what you've just done is load an image, okay? So you've just loaded an image of a calculator, and now you're ready to take some programming work, right? Each one of you. So team 1, let's just do a practice problem, and we're going to do 2,400 divided by 30. Okay, so we should all have the answer 80. And if you're on team 1 and you don't have a calculator up yet somewhere, can you raise your hand so I know? Okay, great. So what this is all about is time. So in the real world, people are impatient, right? We know that people are not very patient generally. And so when they go to a website or an app, they have a very low tolerance for delays. So you guys are going to get to experience what that's like to be a pod and to be under high demand. And we're going to time how long it takes you to do calculations on your calculator. Hopefully, we're on a level playing field because we all have calculators. This isn't about us doing the math. It's just kind of an exercise to learn together. And it's just fun. So there's no real competition here, guys. Hope you know that. Okay, so if we pull up our list of people, and we have Austin, Ty, John, and Gunther. Now we are going to start off without a load balancer. So what that means is it's essentially random who will be picked when out of these 4. And it could be the same one every time, which is kind of weird. But without a load balancer, that's the kind of behavior that we see, is really random. And it's not very predictable. Okay, so I'm going to time you. And as soon as I say your name and the problem, you can start, okay? So I'm going to say your name and a problem. So it's going to be division. And I'm just going to write the problem right here so you can see it, and then I'm going to erase it after you get the answer. Okay, so Ty, it's you. And you can give me up to 2 decimal places. So we're going to say 2, 3, 4 divided by 5, 6. Go.
Done. So
Okay,
it's
what is it?
4.17.
Great. So that was 2 seconds. Pretty good. Okay. So we are going to do another one. And I guess I'm going to have to work out a better way to do this. Hold on. Do one above this. Make it a little bigger. All right, we'll do the problem up here. Okay, it's going to be tie again. And the question is 76543 divided by 2.
Done. It's 38,271.5.
Thank you. And can anyone guess how much time it took tie the second time? Two seconds again. So tie's pretty consistent. Okay, this time it's going to be Gunther. And we're going to say 37928 divided by 4.
Had to unmute myself.
What'd
Yeah,
you say? Okay.
37928 divided by 4 is 9,482.
Thank you. Okay. I think it was about 10 seconds, and we know there was a mute delay there, Gunther, so we understand. It's just kind of a fun exercise. All right, we're going to say John, and the question is 60, 30, 28 divided by 4.
15,082.
Job. That was about 3 seconds. Okay. Austin, the question is 985437 divided by 8.
Got it.
Okay.
1,231,790.87.
And that was in about 1 second. That's pretty good. Good job. Okay. So I should have done an average. How many questions did we do? Everybody had 1 except Ty had 2. So does that make it 5? Did we do 5 different problems? Does that sound right? Okay. So the average response time is equal to 18 divided by 5, which is 3.6 seconds. Okay, cool. So how do you feel most people would feel about that on a website? Let's give thumbs up, thumbs middle, thumbs down if it took 3 seconds to get the answer. I'm just curious. Got a lot of sideways. We got some downs. I don't see.
Look, I live in North Idaho. We just got internet. Pretty happy with whatever works.
Cool. Okay, let's do another round with team 2 this time. And team 2, you're going to do multiplication. And just to remind you who's on that team, it's David, Nancy, Andrew, Lauren, and Zibia. So we're going to do the exact same thing this time, except it's with multiplication. If you're on team 2 and you don't have a calculator handy, can you raise your hand? Okay, and remember, we don't have a load balancer, so it's going to be kind of random. Some of you might get called twice, some of you might not get called at all. And that's kind of how it is when you're running in that mode. They call it headless because you don't really have a brain. You just kind of do stuff when you feel like it, but there's no brain telling you what to do. Okay, because that's what a load balancer kind of is. It tells which pod what to do when. I'm kind of pretending like I'm the load balancer, to be honest. Okay, Nancy, the question is 3, 4, 5, 6 times 3.
10,368.
Very good. 2 seconds. Not bad. Okay, Lauren, the question is 765,432 times 5.
3,827,160.
Good. 2 seconds. Very good. Okay. David, the question is 8,126 times 2.
16,252.
6 seconds, or 2 seconds, sorry. The total is 6 so far. Good job. Okay. David, the question is 7,896 times 4.
31,584.
Good job. I've noticed one thing is that people tend to be consistent about how fast they do stuff. Zibia, the question is 5,678 times 4.
22,712.
Good job. Okay, did we do everybody on your team?
No.
Andrew.
Andrew, you didn't get to go?
Yeah.
Dang it. Okay.
Oh, David, you took all of it.
Sorry, man.
I was ready here, huh? Okay.
Okay, that's kind of normal. Okay, for kind of what we're doing. Again, we're not using a load balancer, which means you don't all get even amounts of requests. That's what a load balancer normally would do. Okay, team 3. Let's see. Team 3 is Josh Elliott, Josh Fulmer, Christian Gonzalez, and Weston. And if you're on team 3 and you don't have a calculator, can you raise your hand? Okay, cool. So it's subtraction this time. No decimals you have to worry about, which is kind of nice. Same format. And let's see. Christian Gonzalez, the question is 3, 4, 5, 6 minus 7, 8, 9, 10. Sorry. Go.
I got negative 75,454. I had done the subtraction without the 10, and then
Okay.
you mentioned it, and so I had to retype it.
That was totally bad. Let's do another one for you. Okay.
Okay.
Sorry about that.
No
Okay.
worries.
6, 7, 8, 9, 10 minus 12. Go.
So I got 6, 7, 8, 8, 9, 8.
Good job. 3 seconds. Perfect. Okay. Christian Gonzalez got to go twice, but he's going to go a third time because we're not really following a round robin protocol here. So we're going to say
That's
1,
right.
2, 3, 4, 5, 6 minus 7, 8, 9.
And I got 122,667.
2 seconds. Not bad. Okay. Josh Elliott, we're going to say 6,543 minus 90.
6,453.
Nice job. Oops. Thank you. Yes. Okay, Josh Elliott again. We're going to do 7, 8, 9, 10 minus 11.
7, 8, 8, 9, 9.
Good job. Okay, so I think we've done four problems. Does that sound right? Except for the repeat, we won't count that. Weston, we're going to do you. The question is 9999 minus 8888.
1111.
Awesome. Okay, so the average is 5 times, so it's going to be 20 divided by 5. Good. Okay, team 4, we are going to do you guys with, we're going to have addition problems. See, on team 4, we have Benjamin Fromm, Preston Gunter, Chris Long, and Robert McGuffin. And by the way, if you didn't get picked on team 3, I apologize. That's kind of how we're trying to learn something here, and that's kind of how it works. Okay, so does anyone on team 4 not have your calculator? Can you raise your hand if you don't have one? Okay, cool. So Robert McGuffin, the question is 5555 plus 9865.
It is 15,420.
Job. Okay, Robert McGuffin again. 77777 plus 88888.
That is 166,665.
Job. Okay, Chris Long, we're gonna do 56789 plus 98765.
155,554.
Good job. Okay, Benjamin Fromm, we're gonna do 23456 plus 76543.
99,999.
That was fast. Good job. Okay, and see, I think we've done 4, and I think we've all got to go once. Wait, no, we've done 5, right? Oh gosh, I should have.
We did 4.
We did 4. Who hasn't gone?
Preston.
That's what I was
Hasn't
thinking.
gone.
Okay, we'll get it. So we did 4 times, so it equals 11 divided by 4. Okay, team 5, lucky dogs, you're gonna get square roots. So that means you need to have kind of a scientific setting on your calculator. If you don't, we can switch to something else. But you should be able to find the square root symbol, which is, for me, it's this one. Can you raise your hand if you don't have a square root function on your calculator? If you're on team 5. So in my case, I'm gonna do 144 square root 12 as an example. Okay, Brother Cantarero, we're gonna do you first, and the question is, what's the square root of 369?
It's 19.
Good job.
20.
Great. And Christian again, what is the square root of 9,768?
It is 98.83.
Good job. Okay, Ronaldo, what is the square root of 576?
84.
Good job. And Besmir, what is the square root of 1,269?
I was muted, sorry. 35.
Oh, no problem. Okay. Okay, so that equals. Okay, cool. Good job. Okay, round 2, we're gonna switch images, okay? So team 1, now you're gonna be doing multiplication. So we're redeploying you with a new image on your pod. So now you're a multiplication pod. And we're gonna use a load balancer this time. So we're actually gonna do round robin. So if you look at this chart, that tells you which order you're gonna get called up in. So Austin will be first, then Ty, then John, then Gunther. So that's how it'll work because we're using load balancing. It's very, very predictable. Okay, so Austin, you're going to be first, and your question is 1,369 times 12.
Got it.
Okay,
16,428.
nice job. Okay, Ty, you're going to be next. 1,248 times 4.
So 4,992.
Nice job. John, you're going to be next. 678 times 33.
Got it. 22,374.
That was really fast. Good job, John. Okay, Gunther, you're next. It's going to be 3,456 times 78.
So you said 3,456 times 78.
Yes.
Oh, there it is, right there. Yeah, never mind. 269,568.
Nice job. And now we're going to do average, which is by 4. So your average went down 1.1 seconds. Okay. Now team 2, your new image, you are subtraction pods. So make sure you're geared and ready to do some subtraction. And your team will be called up in order as well. David first, Nancy next, Andrew after, Lynn, Lauren, then Zibia. Round robin style. Okay, this is what a load balancer does. Make sure everyone gets the same amount of work. So David's first, and your problem is 1166 times 1238.
It's 13,823,508.
Good. Thanks, David. Nancy, your problem is 3,333 times 12.
Um, 39,996. I was going to be doing subtraction.
Oh, dang. Reverse that. Sorry, guys. I can do this. We'll do it. We'll do another one. Thanks, Nancy. Okay, your question is 7,809 minus 11.
78899.
Good job. Okay, Andrew, yours is next, and it's going to be 3333 minus 444.
That's 1,111.
Thank you. Good job. Okay, Lauren, you're next, and it's 76543 minus 21.
76,522.
Good job. And Zibia, you're last, and yours is 4356 minus 721.
3,635.
Good job. Okay. And there's 5 on your team. 5. So your average did go down by 0.2 seconds. Pretty close though. Okay. Team 3, you will be doing addition. So you need to download your addition image. Be ready to do some of that. And we'll go in order again. Josh Elliott, Josh Fulmer, Christian Gonzalez, and Weston Jones. So Josh Elliott, you are first. And your problem is 9,678 plus 1,231.
You know, Don Wilkes Booth's most famous role was actually Julius Caesar in the play Julius Caesar.
Wow, Julius Caesar from the hit play Julius Caesar?
8,447.
When's Julius Caesar gonna get into Smash?
Okay. And Josh Fulmer, you will be next. And yours is 1,234 plus 576.
It just disappeared. 1,810.
Thank you, Josh. Christian Gonzalez, yours is next. And you will be 2,345 plus 12.
I got 2,357.
Good. Thank you. And Weston Jones, we're going to do yours next. 3,456 plus 7.
3,463.
Good job. Let's see, we're in team 3. There's 40 guys. Here's one up slightly. Okay, and let's see, team 4 will be next. Load your calculator square root image. And again, so you'll be doing square roots. And if you don't have a square root function, please raise your hand. Let me know if you're on team 4. Okay, cool. So again, just for review, so it's going to be like 144 square root, something like that. Okay, and you'll be called up in order: Benjamin Fromm, Preston Gunter, and Chris Long, then Robert McGuffin. So Benjamin Fromm, your question is, what is the square root of 169?
13.
Good job. By the way, I'm curious if you did that one from memory.
Yes.
Good job. I think that was about 1.5 seconds. So why would it be faster if you already know the answer? Why would it be faster to get the answer if you already know it? Obvious question, but I have to ask.
I didn't have to do the extra steps to find the solution.
You didn't have to
Already
do
knew it.
computation, basically. Is that what you're saying?
Yep.
And then Zibia, what were you saying?
I was like, I was about to say, you don't have to take a lot of time and stuff. You have the solution right in your hand, so
Yeah.
you solve it immediately.
Yeah. So you're just retrieving. You're not doing any actually, you're just pulling it right out of memory, right? You don't have to do any extra step. And that works with computers, by the way, guys. If a computer is asked the same thing several times, then if it's a good one, if it's smart, it keeps that answer in hand. So if it's asked again, it just gives the same answer. And it's really fast. It's called caching. That's what it's called. Okay, Preston will be next. And you are going to be asked the square root of 12,089.
35.9.
Good. And Chris, you will be next. And you're going to be asked the square root of 1,369.
37.
Good job. Okay. And Robert McGuffin, you're going to be the last one on the team. Square root of 569.
That is 23.9.
Okay, that was really fast. Good job. Okay, so the average on your team is you have 4 students divided by 4. You went down by 0.125 seconds. Good job. It looks like a trend. On average, teams are going down this time. Okay, so, and we're going to do round robin again for team 5. Load the image of calculator division. So be prepared to do division computations. And we're going to go in order: Christian Conterero, Ronaldo, gosh, I know your name, Besmir, and then Josh Riddell. Okay, so Brother Conterero, your question is division. And so it's going to be 456 divided by 12.
47.7.
Good. That was like 1.5. That was really fast. Good job. Okay, Ronaldo, your question is going to be 1275 divided by 12.
Is 106.25.
Nice job. Okay, Besmir, yours is going to be 369 divided by 3.
123.
Good job. And Josh Rattel, your question is going to be 479 divided by 5.
95.8.
Good job. I think your teams went down quite a bit. 4 students divided by 4. Yeah, look at that. Okay, so this was kind of a silly exercise. What do you think of this? What are your general impressions? I'm curious if we should do this again in my next class or not.
Yes.
Load balancing, good.
Load balancing, good.
Yeah, I agree with that.
Well, I think you're going to take it a step further, right, with the pods idea and explain. And so I think don't judge it yet, guys, because I think that now that you've lived this, you're going to be able to visualize the next step very well.
Yeah.
So I'm sorry. Go ahead, Brother Murdoch. Keep going.
No, you're doing good. Thanks. I just want to hear any comments in general, things that were going through your mind as we were doing this.
Okay, so one of the things that was going through my mind, maybe this is a question. So how do you translate this into technology world? What is this?
Good. Very good question. So in almost all cloud frameworks, all cloud frameworks, all cloud technologies have something called a load balancer. All of them have it. So Amazon has one, Azure, Google. And what a load balancer does is, like, I was the load balancer, okay, in this game. So I chose who had to answer which questions. And the purpose behind that is there's lots of purposes. But one cool thing, if you look at the way Google's works, it's really interesting. I was just reading about it this morning, but they have this idea of what you can do with their load balancers is very interesting. It looks like this. So what happens is, if you're in China or in Asia, say you're in Europe, or you're in Southeast Asia, or different areas of the world, they have these things called edge nodes. And this is a pretty popular idea. So what happens is, depending where you are, say you're in Africa, India, China, and then depending where you are, what happens is the load balancer will actually take your request and route it to the closest data center to where you're physically located. What would be the advantage of doing that, of routing traffic to the closest data center?
Gets there quicker.
Absolutely. Physics are at play. You might not think about it, but there are physics involved in data transfer. So if it's closer, then it will take less time.
What really is the time difference? Is it like a couple of milliseconds, half a second, 1 second?
So it can be seconds. So you can go, like, if you're in Africa and you're talking to an Africa data center,
yeah,
you're probably going to be like 0.03 seconds.
Okay.
Would be like an ideal, probably. And then if you accidentally, or say you don't have an Africa data center, okay? Let's take this out for a second. And instead, you're having to talk to India.
Yeah.
That could multiply it by like, oops. Let's get the right shape here. it will change it to probably like 4 seconds or 3 or 4 seconds. So say it 3.
Okay. So it is significant.
Yeah, it's really significant. You would think by now the world would be operating in a way that isn't the case, but we actually have experience at BYUI that shows us differently. Working with students who are online, we've run into this exact number, about 3 seconds. And in this case, they're actually going to Virginia from Africa. And that's a big bottleneck that we're seeing. So load balancers give the opportunity to smartly route traffic based on application and location. So another thing that it can do is say you have videos, say you have YouTube is running in San Francisco, okay, which it is, but it's also running in other places. I'm just making up San Francisco. Maybe that's not really true. But then you have Gmail, and Gmail is running in New York. But say they're both coming from the same person, right? So depending, this is me, depending whether you're asking for YouTube or Gmail, they would route you to different data centers as well, because this is called application specific routing. It's based on the type of application you're looking for. So it's load balancers are very smart. They can be, and intelligent about what they do and where they send traffic to. There's a lot of really cool things about them. But the main thing, if we're talking in just Kubernetes, the main thing is they ensure that your traffic is evenly distributed amongst the different pods. So we're actually going to try working with something similar to this today. We're actually going to use Google Cloud to manage Kubernetes pods today, and manage how many of them are listening. So one thing we didn't go over in the game is a lot of times the amount of requests that are coming are so fast that you can't keep up with them with a single server or pod, and you have to have multiple pods that are responding at the same time. If I look inside of, let's see, this one, and if I go to workloads, we will see that if I go to Kubernetes workloads, that each of the deployments has only one pod listening, right? Now, we in real life wouldn't have it set up that way if it was a popular website. If it wasn't very popular, then one pod could keep up with all the traffic. But in a real popular website, you might have 5, 10, 50, 100 pods listening for traffic. Any questions about this so far?
So if you two didn't have servers on the East Coast and the West Coast and maybe like Central, then it would be slow for someone in the country.
Yeah. So I'm right now. Go ahead.
Goes along with other countries. If they didn't have a server in Thailand, then Thailand would be really slow.
Yes.
So
Yeah.
the more servers you have, the more people can reach it.
Yeah. So let's look at a map for Amazon's data centers. There we go. So all the blue dots are where they have data centers. Where's Thailand?
It's right, yeah, below that blue one to your left. go over to the left and down just a little bit,
Okay.
and then right to the left. That little like skinny point, that's part of Thailand.
Okay. Close to
Yeah, that's
here.
like that's Cambodia, Laos, Vietnam.
Okay. Gotcha. I'm really bad at geography. So this, if you were somewhere far from these dots, then you're going to have a worse experience. Now look at Africa. It doesn't look too good, right?
Hmm.
That's the problem we're having right now, is a lot of our students in Africa don't really have good connections to Canvas because Amazon isn't there. Good question. Well, I want to introduce you guys to an assignment that I think is going to be an interesting one for you. Let's see if I can find the right tab that I have open. I don't know if I can find it. Here we go. So let's see. I will show you this assignment. And this is Wednesday, so I think we're going to have it due by the end of the day, Friday. There is a lab tomorrow. I'm going to show this to you. So you're welcome to come to the lab if you have questions. But this is the scenario. You land your first job and your boss informs you that they run their website using Kubernetes, but they have not set up any auto scaling. That means that when they get more traffic, they have to manually scale up the pods to take more load. He informs you that it's your job to stay late tonight and monitor the website, adding more pods if they're needed. Also, he reminds you that to stay within the budget, you need to be sure to scale them back down after the traffic settles down. So these are the steps, and I'm going to go through it right now. So you guys might want to watch this. I'll send out the recording of class today, and then you're welcome to stay after if you have questions. You're welcome to come to the lab tomorrow between 2 and 4 at the same Zoom room as class. You can email me with questions. Those are all ways that you can get help, okay? So I'm going to follow these steps. So the first thing is to go to console.cloud.google.com. That comes up in a new tab. Then I'm going to make sure that I'm logged in using my BYUI email, this one. And that pops this up. Then I'm going to go ahead and choose the 262 project. I'm going to go to Kubernetes engine. Sorry, before I do that, I'm going to click this Activate Cloud Shell. Doesn't really matter which order you do it. This is something we've used a little in class, but not a ton. So this is just 4 over from your avatar, this Cloud Shell icon. If you click it, you'll get this black console at the bottom of the screen. And this is a Linux command line, so you can do all kinds of commands using it. Okay, so that's there. Now I'm going to go to scroll down to compute, and then I'm going to go to Kubernetes engine. And I'm going to select clusters. There should only be one. And I'm actually going to click connect. And it gives me a command to connect to the cluster from the command line. So I'm going to copy this command to the clipboard. The easiest way is just to click this little copy icon. Then I'm going to paste that command into the command line. Enter. Okay, now I'm pointed to the Kubernetes cluster, and I can use a command called kubectl. Some call it kubectl. So with this command, I can do all kinds of nifty things, like I can see all of my pods. Pods are the same as workloads. you guys were pods today for our exercise. So if you look at it, there's a lot of them that are in pending status or running status. If you want to, you can just use, let me see one that's running. I'm going to go ahead and follow the directions. So let's see. Now I can interact. I type kubectl get pod, see all the pods running. Now I notice that the website that I'm in charge of is not running. Okay, Sean's page is not. It's not running. Okay, so I'm going to go ahead and say kubectl scale deploy Sean's page -- replicas equals 2. And that should bring it up to 2 pods. Now there's something weird with mine, and I'm actually going to update the assignment right after class. I'm going to give you guys the name of a pod that you can interact with in case yours is like mine and it's not happy. I'm going to give you one that should work for you. So when I hit enter, see what happens. I'm guessing it'll just still say pending. Sean's page. Oh, look at that. There's 2 of them now. So I would take a screenshot here, and then I'm going to go back down to 1. And that's going to bring me back down to 1 pod. Okay, any questions? This will be due end of day Friday. I'll make it available today.
Thanks for putting the instructions on there. That'll be helpful.
You're welcome.
Yeah. What time was the lab tomorrow again?
2 to 4.
2 to 4. I always keep saying I'll go, and then something happens. Sorry.
It's not. There's no commitment necessary. Just if you have time and you need help, you can come.
I think I can come for 30 minutes. I have a class at 2:30.
Okay.
Yeah.
That's perfect. That should be plenty of time. All right. Have a great day, guys.
Thanks so much.
Thank you.
Murdoch, do you have a few minutes?
Sure.
So I saw the feedback that you gave me for fixing my program.
Okay.
I think that's the issue as well. But for some reason, I tried all different names and it just doesn't work.
Okay. Can you remind me which particular issue yours was? Because I was looking at a lot of them.
It was the deployment part. You made the you made your KB article based on my issue.
Okay. Let me just pull that up here. Cloud documents. This one?
Yes, that one.
Okay, good. Now in here, did you go to this show details button?
Yes.
Okay, can you share what can you share your screen and we can look at that together?
Mm-hmm. So, let me see. Have to remember, where did I go?
I'll send you the link here. Oh, that link doesn't work because I'm still working on getting it online public. Okay, so you go to the, okay, you're running the job.
Where did I go to see the error?
You would want to go to Kubernetes and workloads. Yeah. Okay, perfect. This is the one we want to click. Mhm.
To this one.
Okay, so cannot pull image from the registry. Okay. Have you seen this error before now?
Yeah. Yeah,
Okay.
I've been having. Mhm.
Okay, good. So actually there's another thing you can do. Can you go to the menu option on the left and then click on, yeah, I have to close this, I think. And then let's scroll down to, I think it's under tools. Container registry, and then images. Okay, David Page is here. Click that. Interesting. It's here.
I wonder if I need to, instead of David Page, I need to put this dash on the name, or
You're saying it's the dash isn't there?
yeah, mine on here, it's not there. Just
Oh
David.
yeah, that's it. That's it. Nice catch. I didn't notice that.
Let's see if that was the issue.
Yeah, I think that's it.
And then push.
Mm-hmm.
There we go. So now, let's see. Should I go back to the trigger?
Yes. And history. It will run it automatically because you pushed the code.
Oh, gotcha. That is the old one, and this is the new one.
Green. That's a good color.
I like that color.
Yeah. Then can you, if you want to go on to one of those, you can look at it. But I think.
Oops. Yes, let's look at this one. Nice. Oh my gosh, finally.
Now, if you click on the IP address, yeah,
This one?
click on that. Yeah.
Oh.
Follow link.
Oh.
You can copy it too. Either one works.
Oh yeah, I copied it already. It worked, right?
Yeah.
Nice. Oh my gosh.
Congratulations.
That's awful just for that little thing.
That's life. That's what it's like to do this kind of job. There's so many things like that, just little tiny things.
Yep, I was gonna be a web developer. After that, a space, a comma. I'm like, nah.
So what's your target career field if you've changed your mind? What are you thinking of now?
Gonna be cybersecurity analyst.
Great.
Yeah, that's what life threw at me.
Oh, great.
Just for
So
the internship. We'll see.
You have an internship doing that?
Yeah. Next semester.
That's great.
So should I just take a screenshot of these?
And will you need a DNS entry, right?
Yes.
Do you have
I got the IP before, so I think I did that.
You got the IP before, so then you should be able to test your DNS entry then and see if it resolves properly.
Well, actually, yeah, there was a point that it didn't let me go further. So I'm just gonna keep just do the DNS. Then after that, should I just resend it or?
Yeah, just upload it again and then send me an email when you've done it, if you don't mind.
Yeah, because there's no way for you to see.
Yeah, it does, somehow it doesn't tell me when people resubmit things, but
yeah, no problem. Thank you so much, Brother Murdoch.
yeah, good job working hard on this. I appreciate you being willing to figure it out at the end. That's awesome.
Yeah, no problem. Thank you.
Yep. Have a good day.
Have a good day, guys. Bye.
Bye.
So I thought that was fun. I thought that was good. And I was thinking that it would even work better face to face in class. You know, like it would be just faster in class. So like when we move to campus, it'll be awesome. It'll be a good activity. You can just kind of like flash. So you can kind of have like, I don't know, like I'm just thinking about like doing it. Like you could have like slides like prepared in advance that say like, okay, multiplication image pod 1, here's your problem, and then just let them decide, you know, like, okay, you guys, you decide who's who at your table, at your image table, is pod 1, 2, 3, and 4, and as long as they know that, then it doesn't really matter. You don't have to know it. You can just kind of flash it up, and then they just shout out the answer. You know, like the right person just goes, oh, that's me, and shouts out the answer. You know, I can see that in the classroom kind of being a, you know, like a scripture chase fun activity kind of thing, you know.
I was trying to figure out how they could collaborate with this setting, and it was really challenging for me to figure out how can they communicate with each other directly.
Yeah, it doesn't work great in Zoom. But it's an awesome idea, and I think it, you know, it gets them that transfer like you're talking about, like now, like the transfer, putting yourself, like applying the knowledge. I liked it. It was good.
Thanks.
Good job. Thank you for thinking about that. I'm sure that took you a while to think about how to do that. So
you're welcome. Happy to do it. What's the plan for Friday during class? Do you have a thought on that?
I guess I don't know.
That's fine. If you need anything, let me know. I'm guessing there will be questions from the homework again.
Yeah. I think what we'll probably do is let's give them, you know, 15 minutes or 5 minutes to ask questions, 15 minutes in a team, and then maybe introduce the lab that talks about the next quick labs that talks about. Yeah. So just introduce it. Maybe we don't go through it, but we just introduce it. I don't know. What do you think?
Yeah. Then it gives them a chance to be a little more self-driven on it.
Okay. Cool.
Okay.
Thank you.
Sure. Have a good day.
You too.
Thanks. Bye.